Convert to Radians, a Pemberton Pre-Calculus podcast. Episode 1. Let's say we have an angle that is 30 degrees, and we are interested in converting it into its radian measure. To convert to radians, we would multiply our angle by the conversion 180 degrees divided by pi. This conversion will allow us to take a degree angle and write it in its radian form. 30 times pi divided by 180 is 30 pi over 180. And then if you can reduce a fraction, you should always reduce. 30 and 180 have 30 in common that you can divide top and bottom by 30, thus giving you a final answer of pi divided by 6 radians. Now let's say you have an angle written in radians, for example 3 pi divided by 2. To convert from radians back to degrees, we can simply replace pi with its equivalent in degrees, which is 180 degrees. So by substitution, we now have 3 times 180 divided by 2 by substituting 180 degrees for pi, and then perform the calculation. 3 times 180 degrees is 540 degrees divided by 2, which will give us 270 degrees, our answer in degrees. 3 pi over 2 radians is equivalent to 270 degrees. Arc length is the distance around the circumference of a circle for a portion of the circle measured by the angle in radians. We have the formula S equals R times theta, where S represents the arc length, R represents the radius, and theta represents the angle written in radians. Let's say, for example, we have a radius of 9 feet and an angle of 60 degrees. Notice the angle is in degrees. It must be converted to radians. 60 degrees converted into radians by multiplying by pi over 180 gives you 60 pi over 180, which reduces to pi over 3. So my 60 degree angle is pi over 3 radians. By plugging it into my formula, S equals R times theta, the radius is 9 feet, and the angle is pi over 3 radians. 9 times pi over 3 is 3 pi, written in exact form. Or if I round the answer to the nearest hundredths, it would be 9.42 feet. The area of a sector is given by the formula A equals 1/2 times R squared times theta, where A represents the area of the sector, R represents the radius, and theta is the angle in radians again. For example, if we had the problem radius equals 12 millimeters and theta was pi over 4 radians, notice my angle is in radians already, so I do not need to convert to radians. I can go ahead and substitute these values into my formula, and so with R being 12 millimeters and theta being pi over 4, by plugging it in and simplifying the mathematics, 1/2 times 12 squared times pi over 4 radians eventually becomes 144 pi over 8, which reduces to 18 pi millimeters squared. Or if I use a calculator by using the pi button and round it to the nearest hundredths, I get 56.55 millimeters squared. To find the exact values for the 6 trig functions, we would need to take an angle, such as 240 degrees, and convert it into a reference angle. To convert it into a reference angle, starting at 0, 240 degrees is right here between 180 and 270 degrees. 240 degrees is 60 degrees away from the x-axis, and therefore our reference angle is 60 degrees. We also need to know what the sine of cosine and sine are in the various quadrants. Down here in quadrant 3, both cosine and sine are negative values. And so we will need this when we convert our problem over into the various trig functions. We also need the 30, 60, 90 triangle, where the side across from the 30-degree angle is 1/2, and the side across from the 60-degree angle is square root of 3 over 2. And we will use these when calculating sine and cosine, in this case, of our 60-degree angle coming from our reference angle. For example, the sine of 240 degrees is equivalent to negative sine 60 degrees. Because 240 degrees has a reference angle of 60 degrees, and because we're in the third quadrant, sine of 240 degrees is negative. By using our 30, 60, 90 triangle, the sine of 60 degrees is square root of 3 over 2. Because sine is opposite side over hypotenuse, which is 1. That's why it's square root of 3 over 2. The cosine of 240 degrees, the reference angle again for 240 degrees is 60 degrees. And therefore, in the third quadrant with cosine being negative, the cosine of 240 degrees is equivalent to negative cosine 60 degrees. The cosine of 60 degrees is 1/2 according to our triangle. Cosine is adjacent over hypotenuse, so cosine of 60 is 1/2 over 1. Tangent of 240 degrees is sine of 240 divided by cosine of 240, using our identity that tangent is sine divided by cosine. If we take our answers from the previous two parts, the sine of 240 and the cosine of 240, we get the fraction negative square root of 3 over 2 divided by negative 1/2. When you divide by fractions, you take the reciprocal of the second fraction and multiply, and thus get negative square root of 3 over 2 times negative 2 over 1, which the 2's cancel. The negative times negative becomes positive, and the square root of 3 divided by the 1 is square root of 3. So the tangent of 240 degrees is square root of 3. The remaining 3 trig functions are simply the reciprocals of the first 3. Cosecant is the reciprocal of sine. The cosecant of 240 degrees, therefore, would be negative 2 over the square root of 3, the reciprocal of our answer from sine of 240. And as the former governor of California would say, we don't like square roots in the bottoms of our fractions. We must rationalize our denominator. So therefore, we need to multiply top and bottom by square root of 3 to rationalize the denominator. Therefore, getting 3 on the bottom. And on the top, negative 2 times square root of 3 is negative 2 square root of 3 on top. So the cosecant of 240 degrees is negative 2 square root of 3 over 3. The secant of 240 degrees is the reciprocal of cosine. Cosine was negative 1/2, so the reciprocal of negative 1/2 is negative 2. And then cotangent is the reciprocal of tangent. So tangent, we eventually calculated was square root of 3. So the reciprocal of square root of 3 is 1 over the square root of 3. And again, as the governor would say, we don't like square roots in the bottoms of our fractions. Rationalize that denominator. And therefore, we multiply by square root of 3 on top and bottom. On the bottom, we will get 3. On the top, 1 times square root of 3 is square root of 3. And so the cotangent of 240 degrees is square root of 3 over 3. Let's say we're interested in calculating the exact values given a right triangle and some of the information of it. For example, I have a right triangle that has a height of 6 and a base of 8, and I have an angle labeled theta. The red 10 that you see in the diagram on the hypotenuse may not necessarily be there, but that is simply calculated from the Pythagorean theorem. Since we have a right triangle, a squared plus b squared equals c squared, and you can calculate the length of that missing side in case it's not there. So the hypotenuse for this problem is 10. So now, to calculate the 6 trig functions, we use our SOHCAHTOA type relationships. For example, we know that sine is the opposite over the hypotenuse. On this triangle, the opposite side from the angle is 6, and the hypotenuse is 10. Therefore, we have 6 over 10, which reduces to 3/5. Cosine is adjacent over hypotenuse, which on the triangle, the adjacent side to this angle is the 8, the hypotenuse is 10, and therefore cosine is 8 over 10, which is 4/5. Tangent is opposite over adjacent. As we saw earlier, opposite side is 6, the adjacent side is 8, so opposite over adjacent, 6 over 8, reduces to 3/4. The remaining 3 trig functions are simply the reciprocals of sine, cosine, and tangent. The reciprocal of sine is cosecant, 5 over 3. The reciprocal of cosine is secant, 5 over 4. And the reciprocal of tangent is cotangent, 4 over 3. This wraps up episode 1 of Convert to Radians, a Pemberton Pre-Calculus podcast. And don't forget, rationalize the denominators.